Okay, next question. This is actually pretty difficult here. It's kind of tricky. The hypotenuse is equal to 15. The other two sides add to 21. Okay, so what I'm going to do is do a quick sketch. What do they mean when they say the hypotenuse? Well, they even said in the question, I just wrote these parts down, but they said the hypotenuse of a right angle triangle. So you got a right angle triangle, and this side's 15. Now, what are the other sides? Well, they're the other sides. You can call them whatever you want. I'm going to call them y and x. Y and x add to 21. Okay, first of all, I'm going to just do let statements. Your teacher might not make you do this, but it's always a good idea, if you're not sure, to let x represent one side, let y represent the other side. You could even say the side perpendicular to x, whatever. We already know that's not, neither of these are the hypotenuse sides, so they're the other two sides in a right angle triangle. Okay, now, I'm going to make up some equations here. Well, I'm not going to make them up. I'm going to get them from the math. Hypotenuse is 15. Look at this picture. What does that tell you? Well, it tells me that x squared plus y squared equals 15 squared. It's equation 1. Now, my other equation is that the other two sides, so the non-hypotenuse sides, x and y, add to 21. So x plus y equals 21. Okay, well, there's equation 1 and equation 2. So what I'm going to do from here is I'm going to do some substitution. Isolate for either one of these. So in equation 2, let's have x equals 21 minus y. So I take the y, move it to the other side, I get an expression for x, and then I'm going to plug that into there. So this is a little bit of substitution in your quadratics unit, because, well, substitution is pretty universal. So this is getting plugged into there. So what I end up getting is 21 minus y squared plus y squared equals 15 squared. There's my equation. I'm going to solve for y. After I get y, I'll go back and solve for x. Ready for the quadratics? Expand this thing out. Now, squared. You can't just square each one of these. You write two brackets. 21 minus y plus y squared equals 225. We'll just square that now. Now, multiply this out. 21 times 21 gives us 441 minus 21y, and then from this negative y minus another 21y, and negative y times negative y is positive y squared. Okay, now that that's done, I can drop the brackets, so plus the other y squared, and that equals 225. Okay, good for that. Now I'm going to rearrange this a little bit. I'm going to take my y's and put them in the front. I like my biggest exponents to be first. So I've got two y squareds. Then I've got negative 42y's, and then I've got 441 minus 225, because that comes over here, and you get plus 216 equals 0. I hope everyone follows where that number just came from. So these two y squareds are right there. These two y's are right there, and then I have the 441, and I brought over the 225, so it becomes negative. So 441 minus 225, that's where that 216 just came from. All right, next thing. Well, solve it. Once again, quadratic formula, or try to factor it. I always like to try to factor when I can see that a common factor comes out. So y squared minus 21y plus 108. Okay, so factor pairs of 108, they get me to 21. Now, I know that they're both negative because they multiply to a positive number and add to a negative number. So two negative numbers that add to 21. Well, 108 divided by, let's say, 9 is 9 and 12, and that'll do it. Let's see that. So y times y gives me y squared. Minus 9 minus 12 gives me, well, multiplies to positive 108 and adds to negative 21. So there's my answers. Well, actually, that's not true. So there's my factored form. And from factored form, my answers are what makes the bracket go to 0, which is y equals 9 or 12. That's weird. This doesn't happen very often. I've got two answers, and both of them are valid. It could be 9 or 12. And the reason for that is because if it is 9, then when you plug 9 into here, 21 minus 9 gives you 12. So if this is 9, the other one's 12. If it's 12, the other one's 9. So really, there's really only one answer here. Therefore, the two sides are 9 and 12 centimeters. Well, let's say the two sides are 9 centimeters and 12 centimeters long. That makes sense? So do you follow that last thing? So if the answer is 9 and I plug that in there, I could have y equals 9 and x equals 12, or I could have had y equals 12 and x equals 9, and in this case, look at that picture, it doesn't matter which one's which. So they're totally interchangeable. Either way you cut that, your two sides are 9 and 12.